Hello, everyone. This is another session of Microsoft Zero to Hero community, a community for the community. And I'm Shahab, the guy who happened to be a software engineer. And today we want to talk about event-driven systems. But before that, let me share some news about the community. And so please go to microsofthero.com. This is our new portal for getting information about our programs. You could see we are also having a Microsoft Backyard and Microsoft Next Gen Heroes. There are two other programs next to the Microsoft Zero to Hero community. And you could also check the calendar for the upcoming sessions. And as you might see there, next month, we will have a lot of topics around AI, Copilot, and all of those things, because why not? They are the hype, and everyone should know how to use them properly and productively in their environments. Also, you could see how to get in touch with us and follow us on LinkedIn, YouTube, and Twitter. And also, you could join the community hub that we have. And as you already know, we are part of Microsoft Learn. This is where we all could get together as a community, the experts, the learners, and learn from each other and grow together. So after saying that, sorry, today wasn't the best day of my life, but we could go further. So today's topic is about event-driven architecture and event-driven systems. And you might think these kind of systems are decoupled from each other. The only thing we need to do is put a message broker or service bus, whatever in between, publish events, and whoever is interested just could subscribe to those events, right? That's not the whole story. So today we have James, who is an expert in event-driven systems and event-driven architecture, and he will tell us more about these concepts. As always, it is needless to say, but be patient, be respectful to each other's opinion, hear each other's opinion first. Maybe there's something to learn. After that being said, let's invite James on stage and learn more about the topic. Hi, James. How are you doing?
Hi, that's good. I'm good, thank you. How are you?
I'm good, thanks. Thanks for being on stage with us. So I would be glad that I'll give the stage to you. And if you have any words before starting the session, feel free to go for it. If not,
I'll just say, if anybody's got any questions, please put them in the chat. We were just saying offline that I can't actually see the chat, but ask them, and Shahab is going to jump in and interrupt me to make sure that I don't go.
I will interrupt you when there's a question.
And if you want to put my screen on screen, and we can start.
So your screen is there, slides there. So thanks. Let's enjoy the session, and I will be in the backstage.
Cool. Thanks, Shahab. So in his best-selling 2014 book, Homo Sapiens, Yuval Noah Harari discusses a history of humankind. And one of the most important points at the core of Yuval's book is that stories and words are the kind of master key that unlocked human potential. When you think about almost anything that exists in the world today, whether that be your religion, your nationality, the company you work for, the current AI hype, all of these things are just stories that enough people believe in. That's what allows us to work together at massive scales. This ability to communicate an idea and all be on the same page is built around this idea of telling stories. It's fundamental to humankind, really. Now, I know what some of you who've joined this might be thinking, that Shahab's just said that we're going to be talking about event-driven architecture, and this James person is now talking about history of humankind. But there's a really important link here. And the link is that event-driven architecture is fundamentally a communication pattern. It's a way of modeling the communication between your systems, whether that be technical communication between two different services, or human communication when you're describing what it is that a system does. The language, the story of your business is what drives its implementation. And that's what you're going to learn about over this next 50 to 55 minutes or so. You're going to learn some of the secrets of event-driven architecture, how you can build event-driven systems from the basic concepts through to some more slightly intermediate patterns. I'm James Eastham. I'm currently a developer advocate at Datadog. Before I worked at Datadog, I worked at AWS for about 3.5 years. I've always been a .NET developer, but don't worry, this isn't going to be necessarily a talk about a specific technology, a specific programming language, a specific .NET framework, a specific cloud provider. This is a talk that's really simply about boxes of lines. And yes, unfortunately, it is one of those kind of talks. And I want to start by being really honest with you all, actually. I've built event-driven systems myself, as Shahab said. I mean, I wouldn't quite call myself an expert, but I've been there, I've built things, I've done things, I've done this at small scale, large scale. And I have got it terribly, terribly, badly wrong so many times, which might make you think that's a strange way to start a talk, to admit that you are terribly bad at building event-driven systems. Why would you want to learn from me, someone who's just admitted that he's got it wrong so many times? Now, I'm sure you have all built something that has failed, that has gone wrong, that hasn't quite worked as you hoped. And I'm sure you learned so much more in that failure than you did when things went right, when things went exactly like you hoped they would. And that's what I want to try and give you today as part of this talk, some practical tips and advice from things I've seen in the real world on how to, and more importantly, how not to build event-driven systems. Now, if anyone has seen me talk before, has seen any of my content online on my YouTube channel or any of my talks online, you'll already know that there's one thing that I love to talk about almost as much as event-driven architecture and systems design and distributed systems, and that is, of course, pizza. So for the rest of this talk, I'm going to get hungry now. I've realized I'm doing this at 4 p.m. in the UK and I'm going to get hungry. This was a terrible idea. For the rest of this talk, you all need to forget your day job. You need to forget the company you're working for, the project you're working on, the problems you've got, because you're now all going to be developers for plant-based pizza, the world's #1 plant-based pizza delivery company. And where you're at today in your system design is that you've already adopted microservices. This is a really, really zoomed out high-level look at your system architecture today. You are building microservices. You've got a good reason for building microservices. Let's not get into that whole monolith or microservices debate. And as you can see from this diagram, all the services need to know where all the other services are. This order processing service is at the kind of core of your system. It's your core domain. It's fundamental to your application working, because if people can't order pizzas, then your pizza restaurant is kind of redundant, isn't it? And you've got these really explicit dependencies to the kitchen, to the delivery service, and to the pickup service. And now the task that you have is to add a new loyalty point service. Now, what you're dealing with here is a form of coupling. And some of you will be familiar with the common saying in software architecture that you should aim for low coupling and high cohesion. Now, cohesion is a relatively straightforward thing. The things that should change together should live together. And you've already kind of got cohesion sorted out because you're building this microservices architecture. You've got these really well-defined services that are changing independently. Now, coupling is a little bit more nuanced. And it's nuanced because there's a lot of different types of coupling. You've got technology coupling. Are you using Java, C#? Are you using Rust, Go, Python? Are you using AWS, Azure, Service Bus? You've got data format and data type coupling. Are you using binary, XML, protobuf? How are you formatting your null values? How are you using camel case? Are you using snake case? You've got semantic coupling. You've got location coupling. And primarily when you are building microservices that prioritize this synchronous HTTP style of communication, you're dealing with runtime and temporal coupling. At the point in time your application is running, any other service it needs to communicate with also needs to be running at that moment in time. And this is a particularly difficult level of coupling to aim for, to work with, sorry. Now, coupling isn't necessarily a bad thing. As Shahab kind of said at the start, I think one of the more dangerous ideas when it comes to event-driven systems is that your systems are decoupled. And they're never truly decoupled. If you imagine two trains on a train track, if you decoupled the trains, half of the passengers wouldn't get to where they want to go. So you're always going to have an element of coupling in your system because you'll need that coupling to get meaningful work done. But there's an appropriate level of coupling to aim for. And that appropriate level of coupling depends on the level of control you have over the endpoints. A fantastic quote from Gregor Hoppe. And what I think Gregor means here is that if you're working on that order processing service, inside that order processing service, maybe you've got 5 or 10 different subsystems. Coupling those subsystems together more tightly isn't necessarily a bad thing because you own the release cycles, you own the APIs, you own the uptime, you own the on-call. Everything is in your control. But once you start integrating with a system outside of your control, maybe that kitchen service or that delivery service, you want to try and reduce that level of coupling as much as you can, because you don't control their SLAs, their uptime, how good they are on call, how well they keep their system resilient. So if it's coupling that is the primary problem we're trying to solve for, why does it actually help to be event-driven? What benefit does that actually give you? And as of right now, remember, you need to create this new loyalty point service. And to create that loyalty point service, to add this new functionality to your system to manage loyalty points, you first also need to go and make a change to that order processing service, because the order service is going to need to make that HTTP call to the loyalty service and say, hey, this order's been completed. I need you to add some loyalty points. And it's becoming really frustrating for you, frustrating for the business, because you can't ship as fast as you could previously. Because of this coupling as well, though, a failure in your loyalty point service, something that isn't necessarily on the critical path of your system functionality, could actually have the knock-on effect of taking your order service offline. Now, of course, this does apply to all the other areas of the system as well. If the kitchen was offline, maybe you would actually want that to stop orders being taken. The other slightly different way to look at this is that actually, should the order service even care about the fact that people are collecting loyalty points? Is that the order service's responsibility to know that these loyalty points even exist? Now, of course, I fully acknowledge I am oversimplifying that massively, and there are ways that you can build microservices to handle these problems. You can use circuit breakers, you can use backoffs, you can use proper error handling. Just because you're building microservices that use synchronous communication doesn't mean your system is immediately going to be unstable. But is there a better way? And this is where you might want to start looking at moving to a more event-driven system. But before we look at how you would do that, what does it actually mean to be event-driven? And the most succinct way I've seen of putting this is something I've taken from one of Martin Fowler's talks about event-driven architecture. At its core, event-driven architecture is about reversing dependencies, about reversing the lines of integration. Now, your order service doesn't necessarily need to know anything about the other services that it's interacting with. The order service just publishes events, and other services can come along and consume those events if they want to. And by the end of this talk, you're going to have made this entire order processing flow event-driven. But first, as I said at the start, language is an incredibly important thing for us humans. So let's make sure we all level set with a shared understanding of what an event actually is. If these things are going to be driving our system, it kind of helps to understand what one is.
James, maybe there is a question which I think could be very fit to what is an event, and also it says, like, referring to Harari's book, can one say that event-driven architecture tells the story of the business? If so, how should we think about technical events that do not have a business focus but are more technical in nature?
That's an excellent question. Can we hold that thought for about a minute and a half?
Amazing.
Because I do get to exactly that point. So there's a slide. Maybe it's not exactly a minute and a half, but I do get to exactly. I will answer that question exactly in a little while, if that's good.
Yep,
sure. It's an excellent question. Thanks for interrupting. Cool. So yeah, what is an event? And an event is an immutable fact. It's something that's happened in the past. It's something that can't be changed. They're a notification that something has happened somewhere else in the system. If you imagine you go to bed tonight and you wake up in the middle of the night and you fancy something to eat, you fancy a midnight snack, because who doesn't? And when you first get up, your room's going to look a little bit something like this, and you're going to go down to your kitchen, and your kitchen's going to be pretty dark, right? It's the middle of the night. And the first thing you're going to do at this point, I imagine, is to hit a light switch, turn the light on. That is going to raise a light switched on event. It is irrefutable at that moment in time that the light has been switched on. You can't unswitched on a light bulb. Now, once you've done getting your snack, you've eaten, maybe you eat pizza because you've just listened to this talk and you've got pizza on your mind now. After that, you're going to hit the light switch again. That is going to raise a light switched off event. It is irrefutable here that the light switched off. The light switched on, and then the light switched off. These things happen. They're irrefutable. They can't be changed. So if that's an event, something that happened in the past, what does it actually mean to be event-driven? And I think this sometimes gets confused a little bit with what I'd call an event-based system. And I think there's a really important distinction between event-based and event-driven, because both things trigger functionality using events. But in an event-driven system, events it's business functionality being triggered by business events. Events are not a new thing in software development. I started my career building Windows Forms applications in .NET, where a button gets clicked, a mouse gets hovered, the window gets resized. And even in more modern cloud ways of building software, if I upload a file to an Amazon S3 bucket, S3 will raise an S3 object created event. Now, these are what I'd refer to as technical events. There's a really clear distinction here because an event-driven system has events that look like this: order placed, pizza boxed, order delivered, staff member clocked in. You could look at two different businesses in the exact same domain, both building an event-driven system, and they'd have two completely different sets of events because they'll have a different way of talking about their business. But they're probably going to have a lot of similarities in things that are event-based. Buttons are going to be clicked, S3 objects are going to be created. And to answer the question that just came up, I would always... You're going to have to work with these technical events somewhere, right? If a user needs to upload a file to a cloud storage location and that raises some event, you are going to have to react to that technical event somewhere. But when it comes to driving other pieces of functionality in your business, I would always recommend having some kind of translation, if you will. So the service that receives that file upload, inside that service boundary, you would handle that S3 object created event, but you would publish externally something that is the language of the business: invoice uploaded, purchase order submitted, whatever that might be. And it really fundamentally comes back to that idea of stories, exactly as the question says. An event-driven architecture lets you tell the story of your business through its technical implementation. Now, you'll often hear this idea in an event-driven system that events are first-class citizens, which is kind of a strange way of putting things, right? What does it actually mean to be a first-class citizen in a system? Now, I'm sure some of you will be familiar with the idea of API-first design. And if some of you aren't, the idea of API-first design is that the first thing you do when you're building a system is to design the API of that system. That means when it comes to integration, you've got this kind of agreed contract. Imagine you've got a front-end team and a back-end team, and you need to add a new piece of functionality that's going to affect both teams. The first thing you would do is agree on the contract of the API. Both teams can then go off and work independently, and theoretically, at least, just stick the two things together when it comes to actually deploy. Now, because when you're building an event-driven system, and if events are the primary method of communication between your systems, your events are your API, which means you should really be practicing event-first design, because your event schema is the contract between your services. Your event schema is the language that your services use to talk to each other. They're also the language that you all as humans use to bring the language of the business into the system design. And when you're thinking about events, it's not as simple as just having events. Some of you listening to this might have also heard of messages and message-driven systems. So are you using messages or are you using events? And actually, events are simply a type of message. And there's three different types of messages you'll often see. There's commands, there's events, and there's queries. Now, the difference between a command and an event is mostly just a statement of intent. Am I telling a system to do something, a command, or am I reacting to something that has happened somewhere else in the system, an event? And then, of course, a query is kind of easy. I'm just asking for a specific piece of data. And then inside the category of events, you've got different types of events. And the first type of event you will often come across is a notification event, sometimes also known as a thin event. This is a really simple, really small packet of data that simply notifies another system that something has happened. And this is where you start actually with your first implementation of an event-driven system at Plant-Based Pizza. You start with this integration between the order service and the kitchen service. Previously, the order service, when somebody submitted an order, the order service would just send a HTTP request to the kitchen and say, hey, I've got this new order. Now, the order service publishes an order confirmed event. And it publishes it as a notification again, a really thin, lightweight event that just includes the order number. Now, the kitchen service consumes that event and thinks, fantastic, we're event-driven, this is wonderful. And then the kitchen service thinks, well, I don't actually know what's on this order. So the kitchen service goes off and makes a call back to the order service to say, hey, actually, can you give me the information about order 1234? I need to know what I need to create. And whilst initially you might think, well, fantastic, we're event-driven, we're using events, this is great. is this actually any better? Because you've still got that synchronous call. It's just happening the other way around now. And there's another potentially more dangerous error here, because actually now that you're publishing this order confirmed event, maybe another service comes along and says, hey, I'm also interested in that order confirmed event. And I also need to make a callback to get some more information. And then 3 more services come along and do the same. And then another one, and then another one, and then another 3. And then before you know it, your entire system is on fire. And I've been here. I've done this. It is not fun, believe me. A core principle you'll often hear about event-driven architecture is that services are unaware of the downstream consumers of their events. And I think this is an incredibly dangerous statement, because whilst this is correct from a functional perspective, you publish an event and some other system consumes it and you don't even know they necessarily exist, you should probably care about what that downstream system might do with that event once they receive it. Which leads us on to the second type of event you will often come across. As a reaction to this thin event where you need this callback, you've got this idea of event carriage state transfer, also sometimes known as a thicker event or a fat event even. Now, this might be an example of that notification event, that order confirmed event that simply includes the order ID. And this is what that same event might look like as a thicker event. You'll see that the state of the order is being carried as part of the payload of the event. This means that now when the kitchen service consumes this order confirmed event, it thinks, well, yeah, I know what all the items are on the order. I can go off and I can go and create the order now. Which obviously leads you all to ask the question, what is the right type of event to use? Hold that thought. I'll come back to that in just a moment. In its simplest form, an event-driven architecture is made up of 3 key components: an event producer, an event consumer, and some kind of message channel in the middle. In this, I've labeled this as a bus here. It doesn't necessarily need to be an event bus, just as there's some kind of channel in the middle. That could be a queue, it could be a topic, it could be a stream, it could be a bus. And you'll immediately notice that the producer and the consumer now have no idea that each other exists. They're almost immediately reducing your runtime and temporal coupling, because now it doesn't actually matter if either of these services are running at the same time as the other service, because you've got this intermediary layer in the middle. The core integration pattern at work here is publish, subscribe. Producers publish events, consumers subscribe to and consume events. Now, of course, not all coupling is removed. Like I said before, this isn't a decoupled system. It's decoupled from a runtime and a temporal perspective, but there is still coupling. And the contract of the event that you publish, the schema of the event that you publish, is the largest amount of coupling you will typically see in an event-driven system. Now, the producers and the consumers here have different responsibilities, if you will. As a producer, your responsibility is to stick to that schema, to stick to a stable and consistent event schema. And you've got that stable and consistent schema from doing an element of event-first design. You try to ensure backwards compatibility where possible. And if you can't, you try and manage that in a sensible way, which we'll come to in a little while. Now, one of the things you're not responsible for, though, as a producer, is you're not responsible for how your events are used. That's the downstream system's responsibility. And one of the more interesting things that you're no longer responsible for are the constraints of the downstream system. If you think about making a HTTP request to any system, you need to care about that system. You need to care about how many requests a second that system can handle, how will you authenticate to that downstream system? Does that authenticate cache data? And do you need to worry about invalidating caches as you send the request? There's all these things that you, as the caller, need to think about that are constraints of the system that you're calling. When you start using events, you now no longer need to care about the constraints of the downstream system, because the constraints of the downstream system are the downstream system's responsibility. As a subscriber in an event-driven system, you're in charge. Your responsibilities are controlling and planning your ingestion rate. Much like when you're exposing a synchronous API, you have no control over the events that come your way. So it can be really easy to overload your own system because an upstream system suddenly starts publishing lots of events. And remember, they don't really care about you anymore. So one thing I always recommend when it comes to designing event-driven systems is to have some kind of buffer, some kind of durable store at the boundaries of your system. instead of subscribing your consuming system directly to the thing that the producer is producing onto, put some kind of intermediary in the middle. That's in most cases going to be a queue of some kind. That way, if a sudden influx of events come in, they're going to build up on that queue, and you can work through that queue as and when you come back offline. Of course, if you're using a technology like Kafka, this is less relevant. There's another interesting and slightly more subtle benefit, though, to an event-driven system. And based on this fact that event-driven systems are built using business events, and I'm sure any of you who've been working in software for any amount of time have had problems with communication, namely understanding what the business needs the software to do. Now that you've got system functionality being driven by events that use a language that is familiar to the business, you can actually go and have really sensible conversations with business people. You could say, how should we handle an order being cancelled? Or how should we handle a payment refunded? And you can map that exact same language into your system. It's much the same way that domain-driven design gave us the ubiquitous language, or the common language across your system. We're taking this one step further and having this business language drive the communication between systems. Because remember, event-driven architecture is fundamentally a communication pattern. It's a way of modeling the integration between your systems.
Good.
So,
James?
Yeah.
Again, sorry for interruption.
No,
do you mind if I bring up another question,
Please,
which is
do.
kind of related to the previous question? So,
yeah.
And what you described so far about the events. Is light switched on in your example? Is it a technical event that is event-based but not event-driven?
Maybe you're reading a bit too much into my analogy there.
Yeah.
I mean, if you're building a system that is the core functionality of the business is managing light switches, then I would argue that is a business event, right? Because the domain of the business is managing lights, so the light switched on thing is very relevant. I mean, I guess you could say it was a technical event, but I think the analogy has maybe broken down a little bit there. I think what I would determine a technical event more as something that is common to all software systems. So things like button clicked or mouse hovered or file uploaded to whatever, whether it's service, whether it's Azure storage, or whether it's Amazon S3, whether it's Cloudflare, there's an event that all these services will publish. So I think the distinction is a technical event will be something that all systems would see, whereas a business event is something that's unique to your business domain.
Yeah, exactly. So correct me if I understood it wrong, but I think in event-driven architecture, everything is focused on the business concept of the events, right? If, for example, I don't know, if we are creating an application like Figma or Miro, even a mouse hover could be a business event for that application and not a technical event. So it totally depends on the context of that business. If I understood it correctly, based on
completely, you're exactly right.
Yeah. Okay. Then just the last question for now is about. I mean, definitely feel free, guys, to ask questions because they are apologizing for asking too many questions.
Yeah.
That's why we are here. Does event carry the state transfer or FAT events imply eventual consistency, while event notifications in events implies a strong consistency, or possibly no consistency at all? Or is there any relationship between these two types of events and consistency?
So I'll talk about consistency a little bit towards the end of the talk. But to answer the question, in an event-driven system, you are always going to be dealing with eventual consistency.
Yeah, cool.
But I'll talk about that. I'll leave it there because I'll talk about that a little bit more towards the end.
Perfect. Then let's continue then. Thanks.
Cool. So if we look at how we could actually now apply this, we've kind of covered some of the more theoretical stuff there about what is an event, what is an event-driven system, how do you think about your events, and let's actually start to apply that now to our pizza restaurant domain. And to do that, let's just have a look at how things work today. So right now today, an order will come into the order service. This is where a user will come along and place an order. And after they've placed the order service is going to make a HTTP call to the kitchen service. Excuse me. Sometime later, the kitchen's going to go off and do its own internal business workflow. Sometime later, the kitchen service is going to say, yep, I've created this. This order is ready to go now. I've created the order. It's been cooked. At this point, if this is an order that needs to be delivered, the order service is going to make a HTTP call to the delivery service. Say, can you go and deliver this order, please? Delivery service will deliver that order and make a call back. And then finally, the order service is going to make that synchronous call to this new loyalty point service to actually add the loyalty points. And if you look at this, you've got quite a lot of inter-service communication here. Now, arguably, the kitchen service could talk directly to the delivery service, but let's not get too caught up in the details for the minute. There's just a lot of communication going around here between services before you even consider a thing like payments or stock management and things like that. And remember, event-driven architecture fundamentally lets you reverse these lines of dependency to help manage these lines of dependency. So you might now be thinking, you've got today this HTTP communication where things are just talking to each other directly. And if you want to start adopting an event-driven system, you first need to actually understand your events. And let's actually revisit this same image from earlier. This, because I think there's something in here that can be really useful for understanding the events in your system. And that is the idea of event storming. Now, if you're not familiar with event storming, it was an idea popularized by Alberto Brandolini. And quoting directly from the event storming website, it is the smartest approach to collaboration beyond siloed boundaries, which sounds kind of useful to me. And there's a lot of different scenarios listed on the website where event storming can be useful, one of which is to design clean and maintainable event-driven software to support rapidly evolving businesses. Sounds incredibly useful. And I'm sure many of you are working in rapidly evolving businesses. Now, it's really important for me to point out here, actually, just because that you're using event storming doesn't mean you have to then go on and build an event-driven system. And equally, just because you're building an event-driven system doesn't mean you need to do event storming. It's just that these two things work really well together. Event storming helps you really understand the language and the domain of the business. And then if you choose to apply that to an event-driven system, then great. Now, this talk isn't going to be a deep dive about event storming. I could probably fill the whole hour talking about that. But I just want to make a note that it's something that you can use. So when you do an event storm, you would typically get everybody involved in the business in the room together. And it is not a technical discussion. That is really important. You've got business people, you've got architects, you've got product managers, you've got developers, you've got domain experts, everyone in the room together. And inevitably, at some point, you'll find two developers off in a corner somewhere talking about Kubernetes and actually just go and drag them back into the room and say, this isn't about Kubernetes, because it should never be about Kubernetes. And what you're doing throughout this process is everyone is sticking events on the wall. So all the events that happen in the system, already created, already confirmed, or all these things are just getting stuck on the wall. And if there's two different people who call the same event a different thing, you group them together and you discuss that later and agree on a common language. Once you've got all of this together, you would then go off and organize these things by time. So you have a big long line of events, the order of things that happen as a user works through your system. And once you've got this semblance of time, you can then start to layer on the commands and the queries as well. So we've got this pizza added to order event. When a user comes along and creates an order, they're going to actually need to add an item to the order. So what would trigger a pizza added to order event? Well, there's going to have to be a command that comes in from somewhere to say, I want to add this pizza to the order. I want to add this pizza to an order. Now, for a user to be able to add a pizza to an order, they're going to need to list all of the available pizzas. And this is massively oversimplified, of course, but what you can end up with here is this recurring theme of what's the query I need to expose to allow a user to do the work? What's the action that user is going to take? What command is that user going to need to submit to my system? And what event is going to then come off the back of that? And by the end of this, you'll have this agreement of the language to be used in the system, as well as a set of events. And this is where this doesn't necessarily need to directly correlate to you building an event-driven system, because this understanding can still be really useful if you're building a modular monolith that's running on a single VM in the cloud somewhere. Like, this still can be a useful process. Now, one of the commonly touted benefits of event-driven architecture is this idea of evolvability, having this stream of events that are being published that any new service or new system can just hook into and start consuming. Sounds quite magical, actually. But you can get yourself into some real trouble here, as I have in the past. So let's come back to this thick event, this conversation of should we use thick or should we use thin events? What happens if you need to change the schema of this event? And this is a situation you all find yourself in right now. You've just gone multi-currency. You're just starting to roll out plant-based pizza all over the world. And you need to start including currency as part of that value field that is currently a decimal. And you might think, well, evolvability is a core benefit of event-driven systems. We're decoupled. This is wonderful. We're just going to change that order value property from a decimal, and we're going to change that into an object. And we've got this new order value object. I'm sure many of you watching can see the potential challenge here. Because remember, you've got no idea what downstream consumers are doing with this data. And you might think to yourself, well, it's only the kitchen service that uses this order confirmed event, and the kitchen service won't care about the value of the order. But what you didn't realize is that there's also an analytics service. And the analytics service really cares about the order value. And the analytics service span up without you knowing about it. Because remember, evolvability is a key benefit of event-driven systems. So now you've just broken a system that you didn't even know existed, which honestly doesn't sound particularly evolvable, does it? And this is one of the challenges you'll face with these thicker events. You might reduce the need for a consumer to call back, but you've just shifted that coupling into the schema, into the contract of the event. So what do you do now? And I need to apologize actually for the next bit of this talk. Whenever I give this talk, I always get really sad at this bit because I'm going to ruin all of your Fridays. You're all going to get pretty upset now. You're all going to get sad. I'm going to put a word on the screen now. And I'm sorry in advance for the word that's about to appear on screen, but it's honestly, it's an important one. And that word is governance. No, it's awful. It's hard to say. It's just bad. It's a bad word. None of us like it. I'm sure all of you have just got feelings of like red tape and bureaucracy, and you're just thinking, governance, this sounds like it's going to slow me down. But it's really important when you're building event-driven systems where systems are evolving completely independently. And honestly, governance doesn't need to be painful. There doesn't need to be red tape. There's a process that you can use that I'm sure many of you are already familiar with. And that is the idea of a request for comment, or an RFC. And what you do with an RFC is that whenever you want to make a breaking change to your event schema, you simply raise an RFC somewhere. You get the opinions and thoughts of other key stakeholders. So you can raise this RFC, other developers and other teams can come along and actually comment. You can still stay completely decoupled. You can still work as independent teams while still having this element of knowledge sharing and collaboration more asynchronous. So hey, you're even making your communication asynchronous as well as your systems. So that's one way you can manage the more kind of boring governance side of governance, of like managing how you actually make these changes. But how can you actually manage this at a technical level? Beyond, you've agreed that you're going to make a breaking change. Everyone's happy. How would you actually go about doing that at a technical level? And as you've already learned, schema design is incredibly important with event-driven architecture. And you can actually use this to your advantage. And if there's one single thing all of you take away from this talk, it is that when you're designing your events, make sure you adopt some kind of defined structure, some kind of common structure to all of the events that you publish. Now, the cloud event specification is one such example specification for doing this. This is just a defined set of properties that all events in your system will have. And I'll just work through these very quickly. You've got this data property down at the bottom. The data property is the actual payload of the event. This is the actual event. What's inside this data property is going to differ from event to event because obviously all your events are different. You've then got this data content type. This tells the consumer what type of data to expect in that data property. Is it JSON? Is it XML? Is it some weird binary format that you've decided to use? You've got expiry time. Now, this is an optional field in the specification, but I always like to point this out because it's a particularly useful one. You can tell the consumer when this event is no longer relevant. The good example is imagine someone orders a pizza and they're probably not going to want that pizza 6 hours, 7 hours, 8 hours later. So maybe you use the expiry time to do that. Or if you're building a stock trading system, a financial system, expiry time will be useful because the stock price can obviously change. Then you've got the time the event was actually published. This is the time according to the producer, of course. And this unique ID. This is a unique ID generated again by the producer at the point of publish. This uniquely identifies this specific event. And then when it comes to this conversation about evolvability, how do we manage these breaking changes? You've got the source and the type up at the top here. The source should actually be a URI. This is a terrible screenshot from me. So this should be an actual URI string that would be https://orders.production.plant-based pizza or whatever that is. And then you've got the type. What type of event is this? And this is an order created event. And you'll notice on the end of that type property, you've got .v1 suffixed on the end. So if you imagine this scenario where you need to make a breaking change, and right now today, you're publishing version 1 of this event, and you're using that cloud event specification. And what you're going to do as a producer for a period of time is you're going to publish 2 versions of the same event. One structured in version 1, one structured in version 2. And actually, you could even give these 2 events the same unique identifier because technically they are the same event. And at this moment in time, nobody cares about version 2. Everybody's really sad. Version 2 is really sad. Nobody cares about it. It's just being published and nobody's consuming it. But at this point, you can then put a message out notifying the rest of your organization saying, hey, we've got this new version 2 event. Here's the structure of it. And we're going to depreciate version 1 30 days from now, or whatever that might be. And make sure you set a depreciation date. That's really important because what you don't want to end up with is supporting 50 versions of the same event. Over time, and when I say over time, probably the day before the depreciation date, all of your downstream systems are going to switch over and start consuming version 2. You can then stop publishing version 1. Which brings us back to the question, thick or thin events? And honestly, I don't think I can possibly give you a definitive answer here. I've gone back and forwards on this myself more times than I care to admit. Sometimes I'm like, well, thicker events, if you use the cloud event specification and versioning, you can evolve that really easy and it removes that need for the callback. But then actually, thicker events give you a lot more to think about. You need to think about governance. You need to think about breaking changes. You need to think about schema management. So does that make thinner events a more convincing option? And as part of my back and forth trying to figure out, should you use thick, should you use thin, I came across Postel's law, sometimes also known as the robustness principle, which says you should be liberal in what you accept and be conservative in what you send. Particularly this second half of Postel's law, be conservative in what you send. Be conservative in what you send out to the external world. So if we look about this in practice, you're only actually going to add data when teams really need it. Remember, one of the core principles of microservices, is that each service owns its own data. So if you start sending data along with the event, does that break this principle of microservices? Now, only sending the order ID in an event, only using thin events and never allowing services to call back is a really idealistic way of doing things, but honestly, it's probably not going to work in practice. So one other way I found really useful to think about this is publish really thin, really lightweight events that only ever contain identifiers. And when you actually think about the flow that a user would go through here, imagine you're ordering a pizza on your phone and you're going to order that pizza to get delivered. So the first thing you're going to do is you're going to add the delivery address. Either you've got a delivery address already stored in your account, or you're going to come on and create a new delivery address. And because you're practicing microservices, the delivery service clearly should own the delivery address because that feels like it should be inside that service. And then when you come along and actually submit the order, you'd simply include the delivery address ID that has been selected in that submit order command that gets sent to the order service. And the order service is just going to store that delivery ID inside its own database. Then when it comes to publishing that order confirmed event, you can simply include that delivery address ID inside that order confirmed event. The delivery service can consume that and say, hey, I know what delivery address 67980 is. Look that up from your database and go off and publish it. The same applies there also to the customer ID. The big takeaway there really is it's always going to depend how much information you include in the actual event. Whether you use stick events, whether you use notification events, there's no one size fits all rules there. Practicing the robustness principle, minimizing the amount of data you store, is normally a good thing. And the real key takeaway there is to embrace some kind of structured schema pattern, whether that's cloud events, whether that's, I've seen before, the metadata data pattern where you split the event into a metadata section and a data section. Whatever you do, it doesn't matter. Do something. And coming back to Gregor's quote from earlier, if you remember, you can also think about things in the context of the systems that you control. So using thicker events when you're communicating between services that you control gives you greater flexibility inside your service boundaries. If you are a developer on the orders service and that orders service has 10 different subsystems, using thicker events there is fine, really, because you own all them services. But once you start publishing things to services outside of your control, make them as thin as possible. And of course, as possible is going to depend entirely on your specific business domain. Now, when you're building event-driven systems, you're of course going to have to start thinking completely asynchronously. You need to think about every part of your system as interacting in an asynchronous way. Now, I know when I first started thinking about things in this way, it was kind of difficult because at that point I was used to just making a method call or a HTTP call and then sitting there waiting for that call to come back and then continuing with the flow of execution in the application code. And switching to this more asynchronous way of thinking can be a little bit of a paradigm shift. Because now you're doing a piece of work, publishing an event, and then maybe your service receives an event back. Maybe it doesn't. Whoever knows. If you think about this kind of core flow of the order service is publishing that order confirmed event. And you know from when you did your event storm, you know that the next logical event in the flow of events should be this order cooked event. The kitchen's finished cooking the order. But there's no way you can ever know when that event is going to come back. Is that event going to come back? Did the kitchen service ever actually receive that event? And this leads to a challenge around consistency. Asynchronous systems naturally lead to you needing to embrace eventual consistency. And let's really to make sure we all understand, again, we're coming with language and language is important. Let's all make sure we understand what the difference is between strong and eventual consistency. And I want to do that through the lens of paying for pizza. So I want you to imagine for a second, you've just walked into a pizza restaurant to pick up your pizza. You've ordered it. You were going to pick it up. You can almost taste it. You can kind of smell the pizza. It sounds fantastic. I'm making myself hungry again. This was a terrible idea, James. And when you do that, before you actually pick up your pizza and take it away with you, of course, you need to pay for that pizza. You need to pay for it. They're not going to let you take that away for free. And at this point, you have two options for paying for your pizza. The first kind of old school option now, I suppose, is to pay with cash, to take out your wallet or your purse, take some money out, hand it over to the cashier. The cashier is going to take that money, put it in the till, give you a pizza, and you'll go on your merry way. This is an example of a strongly consistent transaction because at this moment in time, you can absolutely 100% categorically guarantee that the payment has left your hands and is with the pizza restaurant. It's guaranteed. If you didn't have enough money, the till was broken or something happened, you would know about it there and then. The second option you have, of course, is to pay with your credit card. Now, when you pay with your card, all that happens is that you're making a theoretical guarantee that at some point in the future, the magic of the modern banking system will move some money from your account into the pizza restaurant's account. And I'm sure you've all been there where you've paid for something, you've taken the item, you've walked out, and then you've thought, fantastic, it must be free pizza Fridays because you've checked your bank statement and no money has actually left your account yet. And then 24 hours later, you check your bank statement again and you realize that free pizza Fridays isn't actually a thing, which is always devastating. Now, this is an example of an eventually consistent transaction. Eventually, if everybody in the world stopped making monetary transactions, everyone's bank's account would eventually reflect how much money they actually have. And there's no real way around this in an event-driven system. You need to embrace it. You need to embrace the idea of eventual consistency. Many software architecture is, in a lot of cases, simply about balancing different trade-offs. And this is one of the trade-offs you need to be aware of if you're going to adopt an event-driven system, is that eventual consistency is something that you have to deal with. So you've now built out a lot of this architecture. Things are looking really good. You've thought about your thick and your thin events. You've thought about eventual consistency. You've thought about your schema design and the events in your system. And you spent all this time building this perfect event-driven system. And then your executives come along, business leaders in plant-based pizza, and they say, yeah, that loyalty point service you've just spent all that time building and you've put blood, sweat, and tears into making perfect, we're not going to use that anymore. We actually just want to adopt a third-party system instead to manage loyalty points. We don't care about this custom-built software. Oh, and actually that third-party system we're going to adopt, it only exposes a REST API. You can't publish events to it, which is frustrating because you've just spent all this time building this event-driven system, and now you've got this thing that doesn't talk event. So how would you actually integrate with these systems that don't speak event, if you will? This can apply to third-party systems. This could also apply if you've got any kind of legacy software, you've got a monolith that's sat on premises somewhere that you can't change or you can't touch. How do you deal with that? And actually integrating with a non-event driven system is relatively simple. And you can do that using the idea of an anti-corruption layer taken from domain-driven design. So what you're going to have is, instead of completely replacing your loyalty point service, you're always going to have some element of loyalty point service or some element of integration service. And that is going to be in charge of just simply receiving those events that are getting published onto the message channel, translating them into a HTTP request, and then making that HTTP request to the downstream system. And maybe you actually publish an event back out if that HTTP request is successful or unsuccessful. Now, I've got a queue in here as well. Again, in a lot of cases, particularly if you're integrating with some kind of legacy system, maybe your new event-driven system is running in the cloud, it's elastic, it's scalable, and you've got this monolithic application that's running on premise, they're going to have very different scaling behaviors. So if you're doing this, having some kind of queue, some kind of durable storage to help ease the load on that downstream system is really, really important. So this is a really good model if you're integrating with something that doesn't talk event. Now, the other really important thing if you're doing this is the idea of observability, how you actually understand what your system is doing when it blows up. And if we come back to that cloud events specification from earlier, there's one really vital thing that's in the cloud event specification. It's kind of tucked away somewhere, and it should actually be more front and center, I think. That there's actually a property in the specification called trace parent. And this is where you would include some kind of correlation ID. Here, this is a proper W3C trace context. Honestly, this could equally just be a correlation ID, some kind of common ID you pass around from system to system to system, because one of the hardest things to understand in event-driven systems is cause and effect, how systems actually relate to each other and how they impact each other. And I've actually got a whole nother talk on the idea of maintaining and evolving and observing event-driven systems. So if you go on YouTube and search for "so you want to maintain an event-driven system," then that's on YouTube as well, if you're interested in checking that out afterwards. But distributed tracing is incredibly important. So how would you actually bring all of this together now? How do you actually start to bring everything together? Because not everything can always be event-driven. And a common question I get asked often is at the boundaries of your system. Imagine you've got a front end talking to a back end. Well, front ends don't really speak event. They're normally going to be making HTTP calls. So how does all of this work together? So at the very boundaries, at the very edges of your system, I'm a really big fan still of having some kind of really thin, lightweight, synchronous API that external systems can call. Maybe that's front ends, maybe that's mobile apps, maybe that's whatever that might be. And all this really thin API layer is going to do is validate the request that comes in, store that in a database, publish that event onto the message channel, whether that's a bus, whether that's a stream, whether that's a topic, whatever that happens to be. All of your downstream systems then can go off and do their work. All that complex business logic is happening asynchronously, and your actual front ends can go on and do other work. But this obviously raises the problem of, how do you get data back to your original synchronous caller? How do you get data back to your front end? And actually, this is much easier than you might think. Because remember, all these downstream systems are also publishing events. So the events, this order prepared event might get published by the kitchen service. And as far as the flow of events go, maybe it's the delivery service that cares about that. Because when an order is prepared, the delivery service is going to go off and deliver it. But your order service can also consume that order prepared event. Your order service can simply consume that order prepared event and maybe just update the status of the order in the database, which means when that GET request comes back into the system to say, hey, actually, what's the status of my order? You've got some more up-to-date information about the status of the order. It's also important to remember that commands can also be asynchronous. Typically, commands are associated with sending a post request to an API. And imagine the scenario where your order service wants to send an email, which is a pretty common requirement in most modern software. In this case, the schema of that send email command is very rarely going to change. There's going to be a to, there's going to be a from, there's going to be a subject, there's going to be a body. That's kind of it, right? And you could build this as a HTTP request response style of integration. The order service sends a send email command to the email service, and the email service responds and says, yep, I've sent that email. But of course, this raises the same problems that actually the email service goes offline. Sending emails maybe isn't a core feature of your business, which then goes on and takes the order service offline. So in these specific scenarios where you've got a command that has a really fixed schema, email, to, from, subject, body, etc., it can actually be really helpful to do this asynchronously. And the first way you could do this is you could do this in a completely event-driven way. The order service publishes an order confirmed event, which the email service consumes and goes off and sends the email. But actually here, the responsibilities are kind of wrong. Here, the actual contents of the email, the subject, the body, the from, and the to, that all needs to be held in the email service because the order service is just publishing order confirmed. Email service needs to then contain all that logic on how to format that email. So what the email service would instead do is expose some kind of message channel, whether that's a queue, whether that's a topic, it doesn't matter. The order service will send a send email command onto that message channel that's been exposed by the email service. And that will contain the to, the subject, the body. As you can see, last time I used this slide deck, I was in Melbourne. And the email service would then consume that send email event and actually go off and send the email. And you'll notice actually in the contents of this event that got sent, this command that got sent, there's this response channel field. This is where you can, as a sender of the asynchronous command, say, here's where I want you to send my response to, which then can be sent back to that response channel. So that's just the key takeaway there is actually commands can be asynchronous too, but in some cases, actually, that can be a good reason to still use HTTP communication. For example, if you are, if there's something on the critical path of your user journey that has to happen before the system goes on and does anything else, say taking payments, for example, that can be something that may still keep as a HTTP call, because if the payment service is offline and you can't take the payment, you probably want to get that back to the user quickly. You want to fail fast and you want to know about that. So again, as always, it depends. So let's walk through this entire flow now. So we've got the order service comes along, a user comes along and creates an order in the order service. The order service is going to publish that order confirmed event, which the kitchen service is then going to consume and go off and actually prepare the order. Eventually, the kitchen is going to publish that order prepared event, which the delivery service is going to consume to go and organize the delivery. You'll notice that the order service has also consumed that order confirmed and order prepared event. That's so that when I come along and I'm furiously refreshing my mobile app, trying to work out where my pizza is, I can get an up-to-date status of the order. Now, there's one final problem that I just want to walk you through here. And it's with this section of the system here. So the post request gets sent to the order service to create the order. The order service is going to store that in a database and publish the order confirmed event. What happens if the order confirmed event fails to publish? So now you've got state written in your database, but the event has failed to publish. Or the opposite problem, maybe the event does get published, but the data doesn't get stored in the database, which is a problem that I've experienced and is incredibly hard to fix. So there's a few patterns that can help you here. And actually, this should be something you're always implementing if you're building a system where you're managing state and publishing events. And that is the transactional outbox pattern. If you're not familiar with the outbox pattern, it's simply that at the point you write data to your main database table, you also write the event you want to publish to another table in your database that you would typically call an outbox or something like that. And you wrap both of those writes in a transaction. That means that if one of them fails, of course, that neither of them get written to the database and you return an error to your user. You've then got this separate independent service that's running and polling the outbox table, looking for any events that haven't been processed, picking those up and actually publishing those to your events. This ensures an element of consistency in that you can guarantee that if state gets updated, the event is definitely going to be published. Now, of course, this gives you an extra table that you need to manage, an extra piece of data you need to manage. I've actually once built an event-driven system that used an outbox, and I forgot to put a cleanup process in place to clean up the outbox, and the system actually went offline because the server ran out of disk space. Back in the days when we used to deploy things to servers, the disk space of the server ran out because the outbox just grew and grew and grew and grew. So there are some things you need to think about with the outbox pattern. So one slightly alternative way of doing this is to use change data capture. If you're using a database service that supports change data capture, some of the cloud databases are particularly good at this. Like Amazon DynamoDB, for example, you can turn on DynamoDB streams, which means you'll then write the stream. All the changes to the database get written out to a stream that you can handle. But change data capture is another way of doing this. Instead of the outbox, you simply just manage the changes to your database and you use that to translate them into events. And that's it. You've done it. You've built your event-driven system. You've taken that synchronous intermingled set of HTTP calls and you've made plant-based pizza event-driven, which is obviously great for plant-based pizza, this completely fictional plant-based pizza company. But what does that mean for all of you? How do you actually take this away now and start actually doing this in your systems? And the first thing I would say is to start small. Don't try to make your entire system event-driven overnight. Pick an area and get that right first. Start small and then scale up. And pick an area of your system that isn't the tier 0 critical, can't go offline ever part of your system. But equally, don't pick something that's so completely irrelevant. If it breaks, nobody cares about it. Pick something kind of in the middle. And then scale up. Something you can also do, even if you're still working in a monolithic system or a system that isn't quite ready for it to be fully event-driven, is to just start adding events. In most monolithic code bases I've ever worked on, or most legacy systems I've ever worked on, to add an extra bit of code that simply publishes events that doesn't actually affect the core feature of the system, it just adds this ability to publish events, is a reasonably low risk change. And once you've got events being published, you then have the potential later to start adding additional features and functionality and service as events. Remember, I just want to come back to this quote from earlier just to finish up. We are absolutely nearly done, I promise. And I want you to remember that at a technical level, of course, event-driven architecture is an integration pattern. It's a way of integrating your technical bits of your system together using business events. But it's also a really useful communication pattern at a human level. One of the hardest things in software development is communication. The language you use to talk about your system between technical and business people, translating business concepts into lines of code is something that is still incredibly, incredibly human. It's something that AI is not going to take away anytime soon. And if the technical people are talking about microservices and REST APIs and service-oriented architecture, business people are going to turn off. Language is incredibly important. Remember, words and stories are the key to human success. An event-driven architecture gives you that language to talk about your system in a way that also gives you looser coupling between your services and a more easily evolvable system that you can extend and change over time. Now, of course, it isn't without its trade-offs. It's not without its silver bullet. It's not a silver bullet. And in this talk, I hope you've learned about some of those trade-offs and you've got some practical things that you can take away and use. All of the actual code of the real application is on GitHub. There's a monolithic app instance. There's a Azure ready microservices implementation. There's an AWS microservices implementation. So it is a real app you can go and have a look at. I've got a whole bunch of content on YouTube if you want to go and check that out as well. And all the slides are available on that QR code as well if you want to grab PDF copies of the slides. And if there's any more questions you have, we can do them now as well.
Thank you so much, James, for all the explanations. There are actually questions. Some of them are more technical about Azure, but let's go through them and answer.
Yeah.
So the first question is, sorry, the wrong one. So does Azure Event Hub provide the similar feature like Kafka?
Excellent question. I don't know. And I can't think I know, but I don't know for sure. I would absolutely recommend going onto YouTube and there's a search from NDC. There's a session from NDC Oslo this year by Daniel Marbach on Service Bus versus Event Hub versus Event Grid. And it literally goes through each service one by one. Here are the features. Here's how to use it. Here's what it does. Here's when you should use it. So go to NDC Oslo, NDC's YouTube channel, NDC Oslo 25. And there's a really good talk from Daniel Marbach on that. So I would recommend going to check that out. I think the answer is yes to answer the question, but I don't know.
Absolutely recommended. As far as I know, they provide like Kafka compatible endpoints, and their shenanigans behind the scenes are more or less the same, but probably not one-to-one feature sets providing from each of them.
Yeah.
Okay, the next question is about, in terms of event-driven systems, do you think deploying EDS on Kubernetes is more suitable, or all with PaaS, like PaaS, like platform as a services, offered by cloud providers?
I'm going to try and remove my bias here because most of the work I've done in the cloud is with serverless technologies, whether that be mostly with AWS services. I've used some of the Azure ones as well. I'm going to try and remove that bias for a minute because you can run an event-driven system anywhere, right? I think one of the benefits of using things like AWS Lambda, like Azure Functions, these more cloud-native services, is that they've got that ability to react to events kind of built into them. Like a core feature of Lambda and Azure Functions is to scale up when there's an event and scale down again when there's no events, right? So I think there's a really natural fit there between building cloud service, using managed cloud services, and building an event-driven system. That's not to say you can't run an event-driven system on Kubernetes. You absolutely can. I know people who do that. There's even KEDA, the KEDA project, the Kubernetes event-driven autoscaler, which is a thing that can auto-scale your pods, your cluster based on message queues, based on metrics. So you can absolutely run an event-driven system anywhere. And acknowledging my own bias, I think it fits nicer with native cloud services that have that scaling built in. Because if you're using KEDA, you need to configure and manage KEDA. I mean, frankly, if you're running Kubernetes, you need to manage and run Kubernetes, right? That's its own job in itself. So you can run them anywhere, basically.
Yeah. Okay, next question is, I think it's regarding the event bus that you had like in the slides as a component between the producer and consumer. And I assume the question is about is Azure service something like that. So the actual question is event bus can be used by Azure Service Queue?
Yes, I think that's bad labeling on my slides. That wherever you've seen event bus on my slides, think of that as just message channel. So that could be a Kafka topic, it could be an Azure Service Bus topic, it could be an Amazon SNS topic. Now, one thing I will say is that in the primary integration pattern is publish subscribe. So you've got one publisher and many subscribers. Queues, so you mentioned Azure Service Bus queues are typically more point-to-point integration. You've got one producer, one consumer. So event buses and queues aren't quite directly related. I've actually got a video on my own YouTube channel that's called Streams Buses Are Queues. What's the difference? That could well be worth a watch, because it's pub sub is mostly topics or buses. Queues are more point-to-point styles of integration, so it's slightly different.
Yeah, absolutely. So I think the key point is that there should be a communication channel anyway in between, and you could use either of them depending on the pattern you're using.
100%. Yeah.
And another question, I mean, how do you differentiate between EDD and BDD?
BDD meaning
behavior-driven design. If I'm wrong, correct me. Guys in the chat, but I guess that's what they mean.
If that's what you mean, I think I've not really used behavior-driven design heavily, but as I understand it, behavior-driven design will be more about the behavior of an individual service. So you might use is it like given when then, like the Gherkin syntax, where it's like given So I think that is how you would design a service, business-driven design. Okay, cool. Yeah, I would see that as how you would design a service. When a user comes to this service, then they do this thing. When they do this thing, then this thing happens. Event-driven architecture is more about communication. It's more about communicating the lines between the actual things, if you will. So I think you would use both, I think, is the answer, if I understand BDD correctly. BDD will be like an individual service. Here's the design of the individual service. And EDA is about how they communicate together.
Yeah, so absolutely could be mixed. And
I always find it. I've seen like stuff online and talks before where it's like event-driven architecture or microservices, and I'm like, that's not a thing. Like they're different. They're different things. You can build an event-driven
on different aspects of the software development, right? Okay, then Ton is also says thanks, but the comment about the eventual consistency, I'm just reading that. If you have any further comments on that, please feel free, James, to tell us about it.
Involving consistent. I mean, I would disagree slightly, Tom, in that if you are publishing an event notification, if you're publishing that onto a message channel that another service is consuming, there is no way you can guarantee strong consistency, because there's no way you can guarantee when the service is going to come along and pick up that event and actually process it. So I still don't think you can guarantee, as long as you've got a message, as long as you've got something in the middle, some kind of channel in the middle, it doesn't matter on the structure of the event. I don't think you can ever guarantee strong consistency.
Yeah, as far as it's asynchronous and you cannot get a feedback whether it's consumed or not, then.
And I will say, I think I kind of touched on it at the end of the talk, but like most if not all event-driven systems I've worked on, they've never been all events. There's been elements of the system where we need strong consistency. Payments is always the example I use.
Yeah.
If you've got a system that's processing payments, in a lot of cases, you don't want to do anything else until the payment has been guaranteed. So you might have that still as asynchronous because you can guarantee the consistency between I've made this HTTP call, the payment service has accepted the payment, it's been taken, right, I can go on and do more things now. Then I can go on and publish an event, for example.
Yeah. I also saw some people like using the request reply pattern over like service bus, like to simulate a synchronous way of components of software talking to each other over an asynchronous mechanism. What's your point on that? Like, do you recommend that approach, or do you think it's an anti-pattern? Or
so could you explain the request reply on service bus?
So this is like I'm sending a command to another component and over a message queue or a topic or something, and then I'm providing a reply channel, like another topic to reply, and then they reply on that, and I'm listening to that reply channel until I get feedback from the other component.
I think that's a perfectly valid pattern. I think that's a perfectly valid pattern. And there's patterns. So like there's what's the name of the actual proper pattern, the integration pattern, like scatter gather as an example, where if you've read any of enterprise integration patterns, the book that Gregor Hoppe wrote, the example he uses a lot on his website is like a loan broker, where you go off and you go off and apply for a loan. That's then going to send a message out, and there's going to be a reply channel, and then there's going to be a fan out where all these different services are going to go and talk to individual banks, and they're going to send all that information back to a reply channel, and then you've got an aggregator that's aggregating that data. I think that where you potentially get into trouble is and I don't think Service Bus does this, but if you're in a situation where you as a developer think it's synchronous and it isn't, it's asynchronous under the hood, but the tooling abstracts that away, kind of like RPC, where like RPC made it think you were making a method call, but you're not. And then you forget about all the problems that come from doing that. So that's the only thing where I think that you need to be careful with using materials in the chat window. Yep, give me 1 second. I can do that.
In the meantime,
I started a little while ago putting I used to have the QR code on my slides, used to go to.
Yeah, I could bring it up again, like if the guys want. Like,
no, I can just put the link. So I used to just link to the slide, and then now I put it on my website, so I can just put the link to my website, and that'll give the slides. Someone's having pizza. No way, Tom. That's sad.
Yeah, I was just about to say they got an event that the pizza is ready at their kitchen. I think there should be a way. If you could send the link from, I will just bring it up for the whole audience, because we have multiple channels and your message is going to the StreamYard, but not the YouTube and the LinkedIn. Here's the link, guys. If you want, go to this to the website from James, and then you could pick up the materials, right?
Yes, that should all be there on that link. And if not, I don't know if we have a way to like share them. We can put them underneath the video on YouTube. Like we can share them on the recording, can't we, as well?
That would be great if you. Yeah, I will just also.
I'll send them all to you via whatever medium.
Thank you.
Link, we can put them all on there.
Okay, then if there's no more questions, there's just one request I have from you. We are giving 50% voucher on all the Microsoft exams from the whether it's fundamental or basic. You guys apply that on your exams. And James, please tell us what was your favorite question in this session.
Just give me 1 second. I've actually just realized that link doesn't work. So I'm just finding another one.
Amazing.
So if I do this one, ignore the fact that it's for Portal. So that will take you to the actual slides, and then we can share the rest on socials, because that first link just didn't work. So use that one instead, and then we can share the rest of the links.
Here it is, guys. And your favorite question?
The one I like, the one Tom's first question, actually, the referring to Harari's book, one can say that event-driven architecture tells a story of business. So how should we think about technical events? Because that's something I feel quite strongly about, that there is this really clear distinction. Like when I was at AWS, I've seen so many people build like the whole system relying on this single S3 object created event.
Yep.
And I'm like, well, yeah, I kind of get that why you've done that, but that's not. And they're like, oh, we're building an event-driven system. I'm like, well, you kind of are, but you're kind of not. Like, it's not really. If you decided you didn't want to use S3 anymore, then you've got to refactor everything. Whereas if you've got this like translation layer that takes that S3 object created event and translates it to a invoice uploaded event, okay, now you've got proper evolvability and you've got the language of your business and everything. So yeah, that was I like Tom's question.
Amazing. It reminds me of like task-based and CROT-based like events and APIs as well.
Yeah, exactly. Yeah, 100%. Yeah.
Great. Thank you. Then, Ton, you could contact us over LinkedIn for the voucher, and we will write you an email for that. And thanks, everyone, for participating. And thanks those who will watch it like on demand later. Enjoyed the session. Thanks, James. It was amazing, as always. And see you soon, hopefully.
Yeah.
Bye.
Thanks, everyone.